Everyone, please keep your mobile phone inside. You will never find time. You have to make time to be successful. Good morning to one and all present here. Small opportunities are often the beginning of great enterprises. In such a way, our college has provided us an opportunity to attend a webinar on emerging technologies in robotics, machine learning, and AWS. It is organized by Department of Mechanical Engineering in association with Institutions Innovation Cell REC and Industry Institute Interaction Cell REC. Now, I request everyone to rise up for REC anthem.
Vandeham Sharadam Visharadam Jnanadam Varadam Vandeham Sharadam Visharadam Jnanadam Varadam Vandeham Sharadam Visharadam Jnanadam Sukha Swachha Swarupini Swachha Hridaya Nivasini Sukha Swachha Swarupini Swachha Hridaya Nivasini Swaprakasha Rupini Swaprakasha Rupini Swaprakasha Rupini Sharadam Visharadam Jnanadam Varadam Vandeham Sharadam Visharadam Jnanadam Varadam Vandeham Sharadam.
Kindly be seated. Now I request Dr. S.P. Srinivasan, HOD of Mechanical, to welcome the gathering.
Checking. My humble salutations to everyone present here. If I say 5G, normally you people think about that whether we got a 5G network in our system or not, whether this 5G is available in our local Airtel or BSNL. You may think about that. But this 5G technology is 3 or 4 years old, if I'm right. But regarding this 5G, China itself, they have filed nearly 1,500 patents. They filed 1,500 types of patents on this 5G technology itself. Still, we have not yet received this 5G technology. I'm just giving you the example of the technology which is going around the world. where all this technology will reach us within a couple of months, we can say. Conventionally, we used to say it may take some 10 years or 5 years. Now it is within a couple of months. We are getting all type of technology in our own table. What we are studying here in engineering is just 47 theory subjects and 17 practical subjects approximately. But those subjects will give you some details about the core engineering knowledge. Initially, we had this mechanical engineering as a basic thing. Now our branches of engineering is diversified, like robotics and automation, mechatronics, aeronautical, artificial intelligence, machine learning, something like that. I don't know, in the next couple of years, there may be new type of branches may come, but for whatever be the type of branches, core is mechanical engineering. The advancement of mechanical engineering, of course, the buck stops here. Mechanical engineering, everyone, all type of engineering and technology must evolve from this mechanical engineering. So whatever be the technology, the core, you have to think about the mechanical engineering concept. So we are trying to bring more eminent personalities throughout the globe to bring about the latest technologies in this robotics and automation and mechatronics, which is going to dominate the entire world. Conventionally, we used to kill a person with the help of some kind of a tanks or other things. Now drones are being used for wars. So of course, drones are based on our mechanical robotics and automation technology. Future எப்படி இருக்குன்னு தெரியாது. வெறும் மொபைல் போன்ல உட்கார்ந்து chat பண்ணிட்டு இருந்தீங்கன்னா you are not in the race. So please interact with the speaker who is available with us, who is having a vast experience in USA. He is having his own startup in USA, in Seattle, USA. Now, as per my request, he has accepted my invitation to address our gathering. Thanks, Babu sir, for accepting my invitation to address our students. And please be interactive. Please be interactive. This is a golden opportunity for you to interact what is available throughout the world. And he's having a set of team members working on this robotics and automation. He's having a separate firm in Seattle. And this is a golden opportunity to interact with these people. And please maintain silence. And please keep your mobile phone inside your bags. If it is happen to see, that will be seized. So please make sure you are keeping your mobile phone switch off and keeping inside your bags. And please maintain silence and please be interactive at the end of the session, not in between. At the end of the session, you can interact with him. Are you okay? Okay, so the session may go for 1 hour, and we are expecting a lot of innovative things should happen in this particular forum. I believe that a lot of takeaways from this seminar. I have a complete confidence on that particular thing. So thank you very much.
Thank you, sir. Success is no accident. It's hard work, perseverance, and love of what you are doing. In such a way, our chief guest is a man of inspiration and honor. He is none other than Mr. Babu Govindarajan, the Senior Enterprises Architect of AT&T Seattle. He is a dynamic technology professional with strong background in software development and proven ability to lead technical team, develop and deliver software solution for any business recruitment. He also provided coaching for middle school and high school. Award-winning first robotic team using machine learning, computer vision, Scratch, Python, and Java for the last 7 years. He also delivered end-to-end solution and solution white paper for critical business requirements using microservice architecture by partnering with application architects, software developers, testers, system engineers, and product owners. He also worked as a software developer for companies such as Boeing, Microsoft, 3M, and Primera Blue Cross using various programming languages such as Java, Python, C++, and C. He worked as a CAD software developer with Integraph and Think3 using Fortran, Python, C, and C++ in India before moving to USA. We are really proud and happy to welcome you, sir. Now I request the chief guest to take over the session.
YouTubeல பார்க்க தெரியாது.
Oh. Hello, guys. I'm Babu Govindarajan. So hope the time that you guys spend here would be useful, 1.5 hours, where I come here to share my experience. Right? I'm not your professors or lecturers, right? Where they can tell you the formal way they can teach things, but I'm just I work in an IT company as an enterprise architect. I mostly interact with the developers across the team. So it won't be a formal lecture, and I'll try to be interesting. So with that, I think already you guys got my introduction. So what we are going to discuss, right? We'll talk about the robotics. So what the robot is like the actuators, which is like the mechanism, right? And then the sensors. I just put this machine learning and computer vision, which is maybe a special sensor. In addition to that, we will talk about the typical sensors in a robot. And then the control system, right? Which is the brain of the robot. So what the robot is, all the human is the most intelligent. We are the most intelligent species, right? All we try to do is imitate something that's similar to human, a machine, so it would be intelligent and it will help us, right? So that's the control system is nothing but our brain, which is the robot brain is the control system. And then I just want to talk about the manufacturing advancement, right? The CAD and 3D printing. what is its role in robotics, right? How it is going to help in 3D printing, in robotics, especially the CAD and 3D printing. And then I'm an IT guy, so it won't be, now I need to talk about cloud or computer or infra, so that's about, there are 3 topics. We are going to talk about the containerization, infrastructure as a service, and the software as a service, right? So this is the overall agenda, right? After that, you guys are free to ask any questions. No question is a stupid question, but answer can be stupid. So don't worry about, feel free to ask questions, right? That's what we are going to do. Okay, so now I'm just looking at my notes. Yeah, so let's go to the next one. Yeah, that's about my profile. Already you guys know my what do I do. Apart from my regular job, I also coach around total 50 kids, me and my other parents and volunteers, other students. They coach around 50 students, the first robotics program. I'm the main coach. There's a website, bothelrobotics.com. That's a website. You will see the programs and the trainings that I offer. So that, and I did my master's in industrial engineering from Guindy College of Engineering. That was back in 2000. After that, I've been working various in India and then US. For the last 20 years, I've been in US. Next is, okay. So what is robotics, right? So the definition I think I just got from somewhere. So the robotics is the interdisciplinary branch of engineering and computer science, right? So engineer in this, so it is mostly, if you say 60%, it is mechanical. Once you get your robot built, your attachment built in the right way, the mechanism built, everything comes as a secondary, right? Which is putting the sensor or even writing a program, which makes the robot smarter. But the underlying is the mechanisms need to be built. If that is good, then you put anything on top of it to make it smart will work. Otherwise, if your mechanism itself is not solid, nothing is going to do any work, right? It will just collapse. So with my personal experience, it is like, it's like a 60% is all about mechanical attachment and building the drive. That's why mechanical engineering is very, very important, right? The remaining, let's say there are 30% is all about programming, whether it is simple Java program or you use the machine learning or computer vision. Everything is that 30%. Maybe the 10% is all about sensors, or again, the sensors are all openly available, right? In the market, you can go and buy sensors and attach it, unless you are some R&D company where you want to develop the sensor. But you will be, in that case, you'll be working as an electronics engineer in those company. So it is just that 10% is that other things, electrical, electronics. Yeah, so then that's one thing. Then that's about the primary thing is the drivetrain, right? So your robot has to move from one place to another place. I'll show you the next, we'll talk about the mechanism wheels, which is used for a robot drivetrain, drivetrain is nothing but your transmission, the motor which moves the robot, right? And then the actuators, we talked about that's mechanisms, and the sensors I have the list of sensors and then the different control systems. We'll discuss that. So this one, I just put some drawings, right? So it is the one that I would like to focus is this mechanism wheels, right? The mechanism wheels are like, you can go the regular wheels, right? Which is on the left side, right? Or your left side, yeah, your left side, the regular wheel, it can go forward, backward. When you want to turn, so you have to like either spin or pivot, depending on how do you want to turn. Like one side wheel would be stationary, the other side wheel will be moving forward or backward if you want to turn, right? Whereas this mechanism wheels, which are it can go forward, backward, and it will also can go left, right. So it is, you don't need to make a turn like 90-degree turn. You can just slide to the sides. That's the reason if you see that it's a special wheels. So that's most of at least the educational robot they use is the mechanism wheels. So apart from these drivetrains, we also have, if you have seen the Boston Dynamics robot, those robots can walk, like it can walk like a human, right? It can jump. So each drivetrain has its own advantage and its disadvantage, right? Anything you put in wheel, it cannot claim a step. So our leg is the most versatile drivetrain. So that's why the Boston Dynamics, their robot can just walk like a human, right? So that's about this drivetrain. And then I think we can move on to the sensor. I have these various sensors, right? So the touch sensor is a simple one, which is, yes, it's a simple, reliable mechanism. Whereas then the distance sensor, right? Distance sensor, I have a sample. Let me turn on. So the distance sensor, normally we use ultrasonic sound, so which is something called the echolocation, right? So if you see bat use echolocation, which is they send the ultrasonic waves, and that wave get reflected based on the speed of the sound. We calculate how far the object is. That's an ultrasonic wave is the one way. So similarly, we have laser, right? Where the laser can be sent, and then you receive the laser and calculate how long it took to receive get back the laser that you sent. So those are the basic concept in distance sensor, right? The color sensors are there are various color. At least this I can show you the color sensor, and then there is a gyro sensor, which is the phones today. We have all the phones are having a gyro sensor, right? That's why when you turn the phone, it automatically flips because there is a gyro sensor inside. Right? And so then today the most sophisticated one is the LiDAR, which is it's a laser. The low I have the abbreviation for it, right? It's a low energy laser that gets sent 360 degree. I'll have that the LiDAR sensor also. We can talk about it. And then the radar it uses the radio waves. Nothing but it's the same as LiDAR or ultrasonic sensor, whereas in case of radar, you use the radio waves, right? The other one, then the other sensor is this machine learning and the computer vision, which we will talk, right? So I just put, so the Lego robot is the most famous even in colleges. The reason is it is easy to build because it's it's very modular. If you want to build a robot in metal parts and you don't know how to build it, so it takes a lot of resource to build anything using metal parts. You have to put a bolt and nut to put together. You have to make perfect joints. Whereas Lego, that's one of the reasons why the Lego is famous is it's easy to build any mechanisms using the Legos because it has all the blocks which are readily available. You can put together a mechanism quickly. And also it is relatively cheap to build a robot using Legos, right? So this, if you see this robot, right? This is a simple touch sensor. This one is a simple touch sensor, which is, it could be in a press to mode or a release mode, the touch sensor is. So this one that you're seeing, this is an ultrasonic sensor, which is, it keep emitting the ultrasonic waves in one direction. It sends in the one direction, and then it receives the same ultrasonic waves. That's how it calculates how far the object is, right? This one, this is a gyro sensor, this is a one-axis gyro sensor. Like, so if you see that there is an arrow, so it's only measures the one axis. If the robot is moving this way, it measures only in the x-axis. So if you turn, either if you turn left or right, it will keep measuring the angle, right? You can reset the angle and then it will keep measuring the angle. And you can stop the motor based on the input, the data that you receive. So this is the gyro. And this is the light sensor, right? The light sensor basically use that, one is to measure the ambient light, right? So when the good example is the car headlight. When you put it in the auto mode, especially during nighttime, it turns on by itself because there is a color sensor which is in the ambient mode. So the same sensor can be used in the ambient mode, which will be to measure the ambient light, right? So if I turn on the light in this room, the ambient light is low, right? If I put more lights, the ambient light is high. So that's the light sensor, right? It can also measure a reflection of a surface. So if black surface absorbs all the light, whereas the white surface reflects most of the light. So if you, so that's a one way. So if you want to, if you see the Amazon fulfillment shop, right, fulfillment warehouse, you'll be seeing the robot on the floor, right? So which uses, and there will be a tapes. They put tape all over the warehouse. So there is a light sensor which is being used in the reflected light intensity mode, and it keeps measuring the surface. So it can track the yellow line or the black line while going, and it goes and get things, right? So that's based on the light sensors. I think we talked about all the 4 sensors. And then again, the drivetrain, it's a simple motor, right? It's a 2-wheel. There is one support in the backside. So it's a 2-wheel drive. And then, so there is a attachment, right? Which is, this is kind of an actuator, which it can go on in this drawing or in this photo. It is bringing the Lego block. That's the purpose of the actuator, right? So this is, I think this is the only thing I can bring. It is very small one to bring over the flight, though there are other, the big robot. So that's just to give an example, right? But before this, you see this. This is a LiDAR, the laser, which is it. This one keeps spinning, right? This keeps spinning. It's nothing but an ultrasonic sensor. Instead of an ultrasonic sound, it is sending the light, harmless laser beams. It keeps on sending the laser beam as it rotates. This will rotate, right? And it also receives the laser beam back. And then it will form a 3D image of the whole room. So you send the robot with this and make it to go over your campus or in the building. So you can plot a 3D map or 3D model. It can create the 3D model. So it's just send the robot, you will have a 3D model of the building available, right? So this is the LiDAR. The car that you guys see is the Waymo, which is a Google's autopilot. It's 100% autopilot. I don't know if you guys know about Tesla. Tesla is not 100% autopilot. It is assisted autopilot. Like it will only, you can use the autopilot only in the highways or the freeway, right? Once you are inside the city, driver should control the car. You should hold the handle or the steering wheel. And so whereas this is Google's, right? This is the Google's Waymo. It's a fully autonomous. There is no steering wheel, no driver, right? So it has a LiDAR. If you see this, it has a LiDAR system, which is very similar to this, except that would be more powerful, right? And it also has a camera, which is the camera that we have. It has the cameras and also the radar, right? These are the main sensors it uses, and it is fully autonomous. You don't need to do anything, but it's very limited. It's not available in all the places. If you go to San Francisco and then Phoenix, which is Arizona, there's another state. Only in those states, this Google is experimenting on this technology, right? Yeah, so the next one is, as you know, in addition to the regular, these are conventional sensors that we saw, right? Now this is more on I'm just comparing between machine learning and the computer vision, right? So both are, so it's what we are going to do with this. It's just nothing but the human eye, right? So we can distinguish any object and differentiate and identify the object. But a robot or the computer is dumb. Computer, you need to tell what it is, right? Computer can't think. So you have to write a program to make it think. Otherwise the program is just stupid. Whatever you write, that's what it is going to do. So what we're trying to do is to imitate the human eye. So the robot can or identify the object in front of it and then take a decision, right? So both even in case of machine learning, right, and then the computer vision, ideally what you have to do is you have to process the image. In case of you have to identify the visual patterns and then analyze the pattern and take a decision. So in case of machine learning is not only limited to videos and images. The data for machine learning could be anything, right? It's not limited to images and the videos. You can provide an Excel sheet with the data and a machine learning. You can create a machine learning model. It's a simple model is slope of a line, right? Where you know the slope formula, right? So using the slope and the intercept, and you can extrapolate house price over another 5 years or another 3 years, if you know how the house price trend is over the last 10 years. So it is, the ML uses any data set, right? Whereas the computer vision uses the images and the videos. So one example of the machine learning algorithm is Google's TensorFlow. That's an algorithm that Google develops. And the computer vision is, there is a OpenCV, which is Open Computer Vision. It's an open source. You can download and start writing program and processing the image. That's on that. Then now we are going to talk about the control systems. Right? The control system is nothing but the human brain, the equivalent of human brain for robot. So we have, these are the 3 Arduino board. Arduino board is there for a while. It has been there for a long time. And then Raspberry Pi. There's something robot operating system, which is they call ROS. So let's. So the Arduino board, right? It is a microcontroller. So what is microcontroller is, you put everything, there's a microcontroller versus the microprocessor. Right? In a microcontroller, you have your CPU, RAM, or read-only memory, ROM, right? Everything is in one, it's a single unit. Whereas in case of a microprocessor, the CPU is different, the RAM is different. They are all, though it is in a single circuit board, it is not, everything is not together. So it is, but the Arduino board is microcontroller based, and it has less RAM and the CPU power is small. It is very cheap, and there is no internet. There's no Wi-Fi support in Arduino board. It's like, I know in Amazon, it is like maybe 400 rupees or like, $5 US, you can buy a Arduino board. It's very cheap. And you can build a robot. All you see is these pins, which is, if you guys see the mouse, these are the pins, right? You can put up pins over their wires and take an output and connect them. If you can see this, there is a 5 volt, 3.5 volt, right? So you can take the volts out, power out from this board and connect to the motors. And also you can connect the sensors. So sensors are what? They are going to send some data to this processor. And based on the input that you get from sensor, you're going to drive the robot. So to drive the robot, you need to power the motors. That's where you can take the voltages from the volt from those pins. So this is about the Arduino board. Next is the Raspberry Pi. Right? This is it's a UK-based company. They came up with this small form factor ARM processor. Right? ARM processor is ARM-processor-based computer chip. So if you see this, this itself supports dual display 4K monitor. So you can connect 2 monitors 4K to this. So these are, this is the mini HDMI or micro HDMI. I think it's a micro HDMI. These 2 are 2 micro HDMI port where you can connect 2 monitors 4K each And this is the Raspberry Pi 4. And then it supports 4 gigs RAM, quad core, 1 gigahertz processor. Right, it's a very powerful computer, which is like $50 US. You can. So why do we need this computer? Because when you build a robot, you cannot put a full computer right on top of a robot. You put a small computer which can process the input and take decision there. So that's what you need, a small form factor robot or computer. In this ROS it's an operating system, right? You have Windows operating system, Linux, Mac. Though it is called operating system, it's basically what it is. It's a set of packages or the libraries that you can use. So it is readily available. So you don't need to write everything from the scratch. Let's say if you want to connect the mouse to your computer, right? There is a driver involved, right? You have to have a device driver installed, right? So it's the same thing happens when you want to connect a sensor to your robot, right? You need to write a drivers. Those things are already available in the ROS. So all you need to do is just take that. They have a Linux distribution also, so you can download and create a Linux, create a Linux operating system, like you can download and then put it in the Raspberry Pi. It comes with everything. So you will be writing a very minimal code to bring your robot alive, right? So it makes things easy. It's an open source. A lot of people contributed to that, and you can also contribute when you develop. So there is something called the gazebo, which we can. It's what happens is, let's say if you want to, the CAD is one thing. CAD you can build the robot, or CAD you can model a robot, right? So once you model the robot, you want to test the robot in the environment. Like you modeled it, but the robot has to interact with the surroundings, right? With the CAD model, you cannot interact with the surrounding because the physical robot is not there, right? So that's where the gazebo comes into picture. So they can create the environment itself, right? And the characteristics of the environment. So you have a model, CAD model of the robot, and then the gazebo provides you the environment. Maybe let's say the robot has to go and deliver food, right? You want to make a 3D or the model of the image. With that you can create the model, road model, or your campus model, and then the CAD model itself can interact with the gazebo model. So you don't need to spend any money, right? All you have is the physical CAD model you created, and the gazebo you created the environment, and you can prototype without creating a physical robot. You can test your designs, right? And then once you are good with your design, then you can go and build the physical robot. So which is very difficult, right? Especially when you build it with the metal parts, it is going to be very costly to build a robot. So you do everything virtually, right? Create that robot, test it. Once you are good with the prototype, then you go and build the physical robot. So that's where the gazebo comes into picture. It's testing a CAD model, and it interacts with the actual physical or the simulated environment. It's basically a simulation. I think these are the robots these are all high school kids, mostly 10th grade, 11th, 12th grade student. They build this robot. I put the mechanism wheels, which I talked about. You can see this robot has the mechanism wheels, right? This one is the latest one, which is this year. Just we finished the teams finished their competition. This robot won for control system award, which is the award given for the robot which uses the machine learning and also sensors to achieve their mission. So if you see, there is a camera over there. This robot has a camera. There's a Logitech camera, right? So this is the Logitech camera there, right? Which is used to, so what we did, uses the TensorFlow machine learning algorithm to detect the object and then do the mission, autonomous missions. It can do automatically using the machine learning. There are some videos that I have in YouTube that I don't know if you guys see, if you can watch. So what, yeah, it uses, I just put the sensors that it uses, right? It uses the gyroscope, which is now it comes as a separate, it is not coming as a separate unit. If you see in this robot, the gyroscope is a separate sensor. Right? This robot has the controller itself, or the main control system, the computer. This is the computer on board, which is an Android device, Android phone. The red color box that you see here, it's an Android device without UI. There is no display thing, but it is an Android phone, Android device. And so that itself has an IMU, which is the inertial measurement unit that comes with a gyroscope, which is 6-axis gyroscope, and also an accelerometer, which will tell you the acceleration of the robot, right? So it has this also used a 3D printer, 3D printed component. If you see this blue thing, it's a 3D printed component. So that's about this one. And this is the 2021 robot. It actually shoots a ring, a flexible ring, a donut kind of a ring that it gets from the floor, it gets from the floor through these wires, right? And takes up, makes a 180-degree turn and comes up, and through this green wheel, it shoots that ring. So that's the mission of this robot. You have to, it's kind of a basketball game. You have to shoot various height. So depending on the speed of the wheel and the angle of the launching pad, you can launch various levels. So this is if you see this, we haven't used any machine learning. This was 1 year older one, right? But it uses the basic sensors. This is the very first robot, which is even very primitive. It has the servo motors and all, but there are less number of sensors being used. So this is kind of an engineering design process. And if you guys are familiar with the engineering design process, it's like you make iterative development. So it's not, first you come up with the idea and then prototype that idea, test that idea, how it works. If it doesn't work as expected or you see any improvement, you repeat the process. Right? So nothing can be done over the night, right? So any progression happens gradually over a period. So if you see, and basically even if you take within that year itself, they come up with a vague idea and then take that idea, create the model, create the prototype and test it, separately test it, improve it. Once tested it, then you go back and revisit your idea and do the cycle. So that's how you come to your, you refine your design. Yeah, so just I want, because I think anything with CAD, we need to talk about the CAD, because any robotics, is not complete discussion without CAD. So what I want to say is this one is, we have SolidWorks, right? So what the SolidWorks is, you have to install the whole software, maybe in your computer or in the college desktop, right? But whereas we have this two softwares, which is AutoCAD Web App and then Onshape. These are all browser based. You can just go and sign up for a free educational account and then create a CAD model. It's all free and you don't need to install any software. So you just use a browser, you would be able to create a powerful CAD model, which is one of the benefit of cloud, which we can talk, like it's as a software as a service. So think about this, even the same slide, I started back in Seattle, and then it was in Google Cloud. I was coming here also, I was editing it, modifying it. So that's kind of a software as a service. The same thing for the CAD model. Like think about a CAD model you can create in browser. That's very powerful. We used to have huge software, install it. I don't know, especially if you are worked in SolidWorks, which you have to work in your college lab, or I don't know, they can also give a student license free, but it takes time to install. It takes a lot of space. Whereas here it is browser. Wherever you go, you have your model, you can still keep working on it. I think that's, yeah. So the 3D printer is now, which I don't have a slide, right? So what you can do is you can prototype. So once you created a CAD model, you can, so once you created the CAD model, right, you can feed there are slicer software available. Each 3D printer has its own slicer, right? You send it to that slicer, which will take that model and then you can print out. So which is like, it's a prototyping. The 3D printer is used for prototype, right? Once your prototype is ready, and then you go for a mass production. So that's, it's used for, it's a very powerful tool. Like if you want to make a custom component, which is not available in the market, you create a CAD model and you will have the component ready, right? Yeah, so that's about the robotics, right? And then we'll wrap up with the cloud. I don't have a phone. I don't know how much time I'm taking. Okay, so the CAD, how much time? So you can go, right? Yeah. Okay, so the cloud is, I don't know why there is a name for cloud, right? It has nothing to do with, there is no similarities. I don't see any similarities. I don't know why it is called cloud, right? All it is it's on demand, right? Whenever you need a computer, you can go to that, whoever is giving the cloud service, you can go and create a computer. So it's on demand. You can go and create a virtual machine and use it. And the same thing, also it is pay per use, right? Pay as you go. Because let's say if you are a startup company, right? You are a mechanical company, you design mechanical products, but you want to host a website, or even you want to create a CAD model or a website, you want to put a data center, and you don't know how many people are going to use. Or think about, you are a game developer, right? You develop a game in your desktop, but when it comes to a lot of people want to use, so you have to put that game you have to host it in a server, but you have to go and buy all the hardware, network, everything. You have to do it. Whereas in the cloud, somebody is already have everything for you. So just go and create the virtual machine, create the network, right? And then go and host this, your gaming software. So people can come and use it. So there is no capital investment. As a startup, you have very limited resource. You want to spend your money on the gaming, developing the gaming software. So you don't want to invest a data center, build a data center. You don't know how many people are going to use. So you can just go and start. If people are more and more people are using your game, so you scale it. That you just pay additional amount. You can dynamically scale. Maybe you host it in one server and you want to host it in 100 server. Just you can automatically scale it. And you don't need to put an initial upfront investment for 100 servers to host your game. That's where the cloud computing is used, right? And there's something called the resource pooling. What it means by resource pooling is, let's say during iPhone release, right? iPhone release, especially the company that I work for, we have iconic release. On that day, the iPhone is getting released, there will be like 500,000 phone orders. From they open 5 a.m. Pacific time zone, which is nothing but 8 a.m. East Coast in New York and all, right? So when they open 5 a.m., there will be it's like 5 a.m. to maybe until 10 a.m. Pacific time. Like that 5 hours, we are going to get 500,000 iPhone orders, right? So to take that much orders, I have to have application, the web server installed in a lot of servers to take the traffic. After that 5 hours, I'm going to sell only maybe 10,000 phones per day, not even like per hour, right? It's 500 hours or the 5 hours, I'm going to sell 500,000 phones. There would be so many users coming to my website, right? And after that, it is going to be 10,000 users maybe for a day. And what do I do with the hardware that I bought for that level of load? It will be sitting idle, right? So it is maybe this. So what happens, let's say when maybe in Christmas time, right? If Walmart is the biggest retailer, so he will get the sales during the Christmas time as a retail company, right? So it is resource sharing is let's both AT&T and Walmart is hosting in Amazon Web Services. So I can use the same resource during Apple iPhone release. And then once I am done with that, I will release those resources. Amazon can use the same resource, same servers for Walmart during Christmas time. I'm just taking the two event where the resources is getting shared across multiple companies when they are hosting in Amazon Web Services. That's what it's called the resource pooling, right? You pool the resource and share across the companies. Hope this is not too much. So it is. So all the things in cloud happen because something called the containerization, right? There's a company called the Docker. They came up with the Docker images. And how many guys know about virtual machines or virtualization? Have you guys used the virtual box, which is, there's a virtual box is Oracle software where you can use to create multiple operating system. So you will have a Windows running on your computer. You install the virtual box. And with virtual box, you can, using virtual box, you can install multiple Linux, you can install Mac. Anyway, you cannot install Mac, is their hardware proprietary. But Windows, the other Linux distributions, we can install any Linux distribution. Whereas in Mac, if you install the virtual box, which is again open source, it is. You don't need to pay for it. On Mac, you can install Windows. It's like one laptop you have, but you have multiple operating systems on the same laptop. That's what the virtual machines are, right? So if you see this on my right side, right, where the mouse is, right? This is, you have your laptop. When I say the virtual box, Oracle's virtual box, that is the hypervisor. On top of that, you can run multiple operating system. Those are guest operating system. So you don't need to spend, if you want to experiment on one operating system, you can just use the virtual machines and do it. But so this is very heavy, right? Whereas the containerization that the Docker thing came, right? What Docker does is it virtualizes the operating system, whereas the virtual machine concept, you are virtualizing the hardware. Hardware is nothing but the CPU, RAM, right? Those are the hardware. You share, like if you have a laptop, which is like 8-core CPU, right? And then 16 gigs RAM. And when you create a virtual operating system, you slice and dice that across maybe 2 OS, or in this case, there are 4 operating systems as per this drawing, the slide. Whereas the Docker is something, this is the Docker here, right? So it has the same laptop. You have to have a same host, which is, it could be a Windows or it could be a Linux operating system. On top of that, you have this Docker. If you know Docker if you have a Docker certification, it's like, hard skill set in computer science. So it is, once you have a Docker installed, and then every application thinks that it has its own operating system. You don't need it. So it virtualizes the operating system. It doesn't virtualize the hardware itself. So that makes it much easier and very lightweight. So it is, this is one of the reason why there is a lot of cloud development happened in the recent time, because of this Docker software. I think so these are the cloud services, type of services, right? So one is the infrastructure as a service, where you just go and ask somebody, hey, I want this hardware. I want a computer, virtual machine, this many CPU, this much RAM, right? Or I want to store my files, just the storage. So they are going to provide the basic infrastructure, right? The storage capacity. You can put whatever you want to put in the storage capacity. They can give you the computer. It's up to you what you want to do with the computer, right? So that's the infrastructure. That's a core infrastructure. You are getting it from the cloud provider. The other is the platform as a service, right? The platform as a service is, they will give you the development tool. Let's say you want to write a software, right? You want to test the software. You want to deploy the software in production machines. So it's a platform. It's not only the infrastructure, they provide all the tools as a platform. That's another level of cloud service. The third one is the software as a service, which we talked about, the Onshape, the AutoCAD, which is a browser-based AutoCAD model that you can create. Those are software as a service, which they provide the software. They won't give you the hardware or the computer or the RAM. You all need to do is subscribe to the AutoCAD subscription, where you can go and create the CAD. So only the software you subscribe for, right? That's a kind of software as a service. And I think these are the top cloud providers. So we have Amazon is the topmost, or widely used cloud service. Then the Microsoft Azure comes next, and then the Google Cloud. So here, if you see the Salesforce, the bottommost, and SAP, these companies are software as a service purely. They don't provide any infrastructure as a service. Whereas the Google, Microsoft, and Azure, Amazon, they provide all the stuff like infrastructure, platform, or a software as a service. They provide everything, right? That's it. So this is all the resources which will be used. So you guys can go to this website and get more detail on the things that I talked about. That's all. If you guys have a question, yeah, I can answer. So the robot that you guys saw, right? So my one is I do for a living, which is my regular job, which is I spend like maybe 40 hours a week, right? In addition to that, I do the coaching for the 50 students. So I'm the primary coach. So I do, my bachelor degree is in civil engineering. I did mechanical, right? Industrial engineering, and then I'm working on the computer platform field. So pretty much I drive everything from structural to programming. So my job is to teaching CAD. I teach them the CAD. We use Onshape as a CAD. Onshape is one of the software. It's a browser based. Just to Google Onshape. I have that in the URL. So you can create a CAD. So I teach them how to create the CAD model. When it comes to the teams building the robot and then programming it. So we use the it is nothing but an Android Studio application that runs in the software on this robot. It's an Android device. So the red color box that you see here, it's an Android device. So they use Android Studio to develop the software. And then, so I teach them Java, and then machine learning using TensorFlow. We're also using OpenCV, which is open source computer vision. It's an API, or it's a set of APIs which you can download and use it. There are other students, high school volunteers. They also teach. They teach the Lego side. So I just maybe moved from teaching. So I started with Lego Robotics. Again, on this one you can use there's something scratch.mit.edu where you can drag and drop the components. Like if there is an if block, for loop, while loop, those things, they have a ready-made blocks. You don't need to type the code. You can just drag and drop the code. So it was like 7 years I've been teaching. So I used the Lego, started with the Lego, and then now I'm using the other students to teach the younger students, so I can focus on the high school students. So that's what I do. Yeah. So you want to save energy, overcome the battery. Alternate energy.
Sir, is there any technologies that can overcome batteries and act as a new energy source?
Yes. I think energy source. Hello. Yeah. Yeah. Energy source. I think there are lithium battery. The primary, if you take any the electrical vehicle, right? Electrical vehicle, the primary source of energy is lithium-ion battery, right? There's alkaline battery that you can use. The lithium-ion batteries. Alkaline battery, the problem is it will not in the cold temperatures, right? Alkaline battery won't retain the power. So that's why they are using the lithium ion batteries, right? Other than battery, there is a hydrogen fuel cell, which is, I think the problem with that technology is it is very costly. To build a car with a hydrogen fuel cell, all it is going to need is a water. Just you put the water and it will convert that. So you can use the hydrogen fuel cell is the one. Other than that, I don't think any other option is available. So.
So as you said, you've done your bachelor's in civil engineering. What made you to step into the field of robotics and cloud computing?
Well, so that's the only actually. So civil engineering, I worked like probably 5 years. I was in Tata Steel, working as a civil engineer. I think one is especially in our country, right? Civil engineering job is very hard. It's hard to survive as a civil engineer unless and until you are an entrepreneur, right? If you can get a contract and build a house, right? You can make a lot of money. If you are just working for someone, you can just make living as a civil engineer, right? And then I think when I was working in Tata Steel, I don't want to do this work forever, right? So I was in it's part of the industrial engineering division, the company that the civil engineering department is part of the industrial engineering division. So I took education leave, so I can go for the industrial engineering. So that's how I was able to get the education leave. No, leave of absence, right? So then you can go back and join your job when you don't get it. Yeah, so it is. That's how I came to do industrial engineering when I joined ME full time with Arduino University, right? And luckily I got campus placement, which is also a CAD development. So that time, I think they still Now the company name became Hexagon Technologies. They are in Hyderabad. It was used previously. It was Intergraph. They make a CAD application. Like you have to develop a CAD software, not a CAD user, but you develop the CAD software using C. And then after that, I moved to Think3. That's another company that also makes a CAD application. So you can do a lot of design. So there I worked for 1.5 years. Then to US. So it's like, I think there's not a lot of people would able to teach the robotics. One is you need a space. You need like 20 feet by 20 feet, just the space to run the robot. And then you should know the civil engineering. To build things, you should know civil engineering. And also you should be a mechanical programming. So I felt this is something I can do rather than teaching maybe Tamil in Tamil schools, right? There are parents who volunteer and teach Tamil. I said, I will do this rather than doing, teaching Tamil for the kids. So that's how I started. Hope I answered your question. Okay. Thank you, guys. Thanks for your time.
Is that necessary all the languages for robotics?
Oh.
Is that necessary to learn all the languages like Java, Python, everything?
Okay. Answer this.
Thank you, sir, for sharing your valuable information on emerging technologies, robotics, machine learning, and AWS. I call upon Dr. R. Shanti, Professor in Department of Mechanical, to give over the guest of honor to Mr. Babu Devendarajan. I request all the faculties to come on the dais.
All the faculty is available in the room. Please come to the dais. Please join with us. All the faculty, please join with us.
Vote of thanks. Now I welcome Dr. Giri Shankar, Professor in Department of Mechanical, to give away the vote of thanks.
Very good morning to all of you. At the outset, it's my pleasure and privilege indeed to deliver the word of thanks. It's not so easy. It's not another task. It's very important because we should not miss out anybody. First, let me thank our management of REC to encourage to organize such a program. Next, I would like to thank our chief guest, Mr. Babu Govindarajan, Senior Enterprises A&T USA, Seattle, USA, for his kind consent within a short span of time. And also he has delivered wonderful presentation. In addition to that, I would like to thank our HOD, Dr. S.P. Srinivasan, who is always committed to continuous improvement, Kaizen, because students wants to know all the things as much as possible in the very crucial time. Next, I would like to thank the staff concerned who have contributed more for conducting this presentation. Above all, I would like to thank you all for your perseverance and patience to learn many things. Finally, I would like to thank all the people who have contributed more to conduct this program successfully. Thank you for the opportunity given. Thank you very much.
Students, the speaker may be available in this room for a while, and if you have any interaction, you can have it, and otherwise you can leave the classroom. Leave the classroom. Thank you.